I guess we'll get started. My name is Jonathan LeBlanc. I'm a technology evangelist and senior software engineer with the Yahoo Developer Network. Basically, my area of expertise is around social application development, a lot of social features, open source software. And really what I want to drive through today are implementing some of those features within payment tools using one of the technologies that we offer within YDN, the Yahoo query language. Now, I normally don't evangelize any technologies that I don't believe in, and this is one that I use regularly with all of my development inside and outside of Yahoo. It's one that we believe in heavily. It's one that we are implementing in our own technologies. We're eating our own dog food, as you would. So this is driving a lot of the products at Yahoo, and we think that it's going to be a very powerful technology for anyone who's implementing any sort of payment systems, basically any application whatsoever. So before I get started drilling down through the specifics of what YQL is, I just want to give you an overview on what it does and what it's supposed to do. So we have YQL as a base. YQL is a wrapper on APIs or services, any data feeds on the net. Its goal is to provide an easy way for you to mash up these data sources, pull them down, whether they be data feeds, whether they be APIs, whether they be internal or external services, or whether they require permissioning. That's the goal of what YQL is. So the way that it started was an idea to allow an easy way to consume Yahoo APIs. So normally when you have to sign up for any API, not just the Yahoo APIs, you have to sign up for individual keys. You get those keys and you read through the documentation, make your own requests, and hey, if you have multiple APIs, you have to take those data sources that are returned back to you and find some way of mashing them up together if you need to correlate that data. So YQL at a base level was supposed to take care of this, to mitigate this concern. And it does it quite well, offering generic feeds, an easy way to manipulate these data sources without actually having to use these same keys yourself. But the team knew that with this, we would essentially have what Facebook has with FQL, basically leveraging off of their internal data source. But we knew that this wouldn't be as valuable of a utility if we just kept it internal. What we wanted to do is externalize this, allow this capability anywhere on the net. So they opened up the feed. They opened up YQL to allow you to select RSS feeds, Atom feeds, any external data sources. Our most popular table is actually our HTML table to easily screen scrape data. Within a minute flat, you can scrape a screen, get all the repeating values, put this in your application. On top of that, they wanted to open up the system even further. What they did was they allowed YQL to wrap any sort of API or data source. We have a community repository on GitHub where people can contribute back what we call open data tables. These are wrappers around APIs or data sources that people can use to get data. So the specific items that we're going to be looking at today around payment systems, around using YQL to build adaptive payment systems, is around delivering upsell content using YQL data sources. So instead, we do not have this payment processing system, because we utilize PayPal for that as well if we need to push users towards that. We have our internal payment systems as well. It's not what YQL is about. It's about getting external data sources and enriching the experience of a marketplace or any sort of application. We're going to take a look at how to drive traffic back to your API, back to your systems, back to your sites, back to your marketplaces using YQL, wrapping your own APIs and data sources. Finally, we're going to take a look at how to mash up data using YQL, using our server-side JavaScript layer in YQL to allow you to take multiple data sources and join them together and return them back to the user. So starting out, let's take a look at how to actually utilize the data to upsell content and enrich your marketplace. This is just a screenshot of any random Amazon page. we have all the no, that doesn't look like this. So we have all the product content at the top left, just on the iPad, information, price points, the standard stuff that you're going to find on any Amazon page. But what we're really interested in here is these upsell boxes. These things here that will allow you to share this content with other people via email, via Twitter, via Facebook, all these social channels. These points down here that say, hey, people who have purchased this product also purchased this. Interacting with the social details of users' purchase history. Offering products that are associated with what the iPad is, such as a sleeve or something along those lines. This is what we're interested in with YQL. So it's no wonder that YQL, the premise behind it, and the tagline that we use is select star from internet. One of my colleagues used to like to say about YQL, our pipes are bigger than yours. What they meant by that was Yahoo has YQL built on our cloud infrastructure. It has a huge amount of servers behind it to process the data. It's a very quick return. If you're in a large company, you already have that. But a lot of companies that are building these new wave products are smaller development shops, startups. And offloading all that data processing onto our systems can be a world of good. They don't have to do it on their servers. They don't have to incur the costs associated with it. It's all done on Yahoo servers. So this is the YQL test console. Think of it much like a sandbox environment that allows you to play with YQL. I'm going to jump over to the console instead of just showing you a screenshot. So let me show you the power behind it. You have up here your YQL statement, which mimics SQL. You have over here, you have the data feeds that you want returned back as XML or JSON. The return value here, so you can just see what the return is going to look like. Sample queries over here, recent queries. And then the table structures that you can pull data from. Something like IMDb, Guardian, Kiva tables, Amazon, Facebook, internal Yahoo tables such as our geo tables and local answers, all that good stuff. But one of the really nice tables down here, the one that's most used, even though we tried to tell developers not to use it as much or for this, is our HTML table. What our HTML table does is it allows you to screen scrape a page, basically inputting a URL with some XPath variables to drill down to repeating values on the page and return back that structure as XML, JSON. So you can see with this standard query, we have all the title tags for the Yahoo Finance page. So just for the non-technical people in the crowd, I'm not going to go over too much code here. I'm going to talk through the services. So I'll try not to lose any of the non-technical folks. But let me show you an example. One of the queries that I like to run. So if I jump over to reddit.com, and I checked this one before, so there's not any not safe for work pictures, which is good. I have a series of title information there. I have some basic titles, and let's say I want to grab that data. If I had Firebug installed in here, that would be great. I could just show you how to drill down to the CSS. But let's take a look at this puppy that I loaded up. So this is the source code behind reddit.com. And those title tags are all surrounded by it's basically an anchor tag with a class of title. That's what we need to know. That's going to give us our XPath so that we can drill down to those repeating values on our console. So let's jump back over to our console and change finance to reddit.com. Let's change our XPath to title. We're looking for any anchor tag that has a class of title. We run this query, and what it's going to do is return back all those repeating query nodes. So what we have now are all the titles off of the page. Less than a minute, you screen scrape the page. It's great for creating your own little scrape PIs, if you would. Just scraping the page, getting the data sources. A lot of people use it for that. It's incredibly valuable, and it's again one of our most used tables. All right, so that's using the console as your sandbox environment for using the system. At a base level, YQL mimics the functionality of SQL. So those of you who are familiar with SQL, you can start working on it right away. Those who aren't familiar, it's just a very intuitive, very easy language to learn and to pick up. I've talked to marketing folks, I've talked to sales folks, CEOs, anyone that really might not have a technical bone in their body, but we've been able to easily talk through the technology behind this and the query syntax of building YQL queries. It's very easy to pick up. Basically what you're doing is you're selecting some piece of data, some key value. It could also be select star for everything, from some table. That could be the HTML table, for instance. You can do remote filtering. Let's say you have 1,000 records that are on that page and you only want to return 50. You can filter that at the remote source, so you only return back this basic paging data. You can further filter the result set using the where, and or clauses, so that allows you to filter that data straight down. You can do local filtering, so different from the remote filtering that's filtering from the source only or the website. Instead, this is the result set that's returned back to you. It's filtering that final result set. In this case, returning back results 10 to 13. And then you can pipe on a couple of functions at the end. It's a couple of method calls. In the YQL documentation at developer.yahoo.com/YQL, they list off a whole series of method calls that you can make. And these will allow you to just see what you can do, like filtering, sorting, reversing the result set if you need to. Going further, we knew that users will not just want to select data. They will want to have a fully RESTful service available to them, supporting insert, update, and delete functionality, much like a normal database might. So they opened up the syntax to allow you to specify insert, update, and delete, much like you would in SQL, same type of syntax. It can be used to do things like creating tweets, updating databases, updating any record or deleting any record where an API supports the functionality. We have several tables currently available in our community GitHub repository for you to take a look at. The community GitHub repository is a great source for sample code. Personally, whenever I know a table already exists that does something that I need to do, I just jump over there and grab that code and use that as my base. So I'll give you the links to that in a little bit. Okay, so one of the other pieces of functionality, in the querying structure, there's not really the case of joins where you can join two tables together. That functionality is embedded within our server-side JavaScript layer within YQL. I'll get into that a little bit later in the talk. But the subselects will allow you to base the result set of one table based on the results of another table. So practical use case, if you have one table that doesn't offer the functionality, the sorting functionality that you need, then what you can do is base that result set for, let's say, latitude, longitude, and find the result set in another table. So in this case, let's say I have a free-form text location, SFO for the San Francisco International Airport. But what I want to do is load up all Flickr photos for that location. Well, the Flickr tables might not necessarily have a free-form text search. So what I do is my inner query, I can just say select my latitude and longitude from my geo places. This is our Yahoo geo table. Again, the latitude and longitude where the text is equal to SFO. It's doing a free-form text search against geo table, returning back latitude, longitude data. From that, I can use the in clause to specify a subselect. So from my Flickr photo search, I can search for all Flickr photos, all geotagged Flickr photos, mind you, where the latitude and longitude is located in our previous query. So that means we can extend the functionality of the Flickr photo search to include free-form text locations. All right, so there's a couple helper commands that are available to you, such as show tables. Really what I wanted to show you here is besides show tables, which will load up all the tables that are in the current context, so you can see all the tables that are available to you. But the really important thing are the number of data sources that are currently available to you. Yahoo has a number of internal tables, things that we specified for our internal APIs, our internal database systems, making requests against HTML data sources such as Atom or XML. We have 169 tables of data that have been provided to you, openly available. It's a completely free service, so you are not required to pay for these. So on top of that, we've opened up the system to allow people to contribute back tables, to contribute back data sources from APIs or external data feeds. From that, over the past year and a half that YQL has been around, we've had 771 tables contributed back to the service, giving us a total number of 940 different tables of data, ranging, you saw the table listing along the side. I definitely recommend taking a look through that. It's an easy way to see what we do offer. There's the link for our community GitHub repository. If you're familiar with GitHub, all you would need to do is clone the repository there, make some changes, and issue a pull request, and we'll add the changes in. All right. Another little good command, one that I like to use myself, is the describe command. You can say describe table name in the console, and what it's going to give you is basically information on what the table is, how to run the table, and its particular uses. You'll have some information like documentation, different URL structures, sample queries, all the good stuff that'll get you started. But for me, the real value comes in allowing you to see all these little keys that are available. You can't really see that point, but they're right down here at the bottom. What these are the mechanisms that allow you to filter from the table. So select whatever keys from the table. So if you're just starting with a table, you can describe it and see everything that you can filter it on. It's very helpful for just getting started. All right, so where the console system is a sandbox environment, we do have a standard URI structure to allow you to make requests out to get the data. It's really just a URI endpoint that you can call with a few query parameters and get data back. It's divorced completely from the console system, which is just that sandbox. You can call one of two URLs. So we have a private URL at the top and a public URL, the one right below it. The private needs to be OAuth signed, and this for accessing information such as social data or any private data we might have stored. The public one is one that most people use, and that's for just accessing public data like scraping pages or accessing RSS feeds, things like that. And most of the tables utilize that. No matter which one you're using, there are a series of query parameters that are available to you, put on the end of the URL structure. We have Q, which is the URI encoded YQL query, so select star from whatever. The format that you want returned back, XML or JSON. The diagnostics information is great for giving you this little diagnostics node in the return value. It'll give you information on how long the queries took to execute in milliseconds, the URLs that were requested, all this information back to allow you to just drill down and see some diagnostics details. Debug is really great if you're seeing caching in the service. If you're setting up your own table or you're accessing your own data source, you set debug to true and caching gets chopped out, so it's really good for testing. And then our callback is a JavaScript function name that you can input with the query parameters. What's going to happen if you input a JavaScript function name here is you extend the format from XML and JSON to include JSON-P and JSON-PX. Simply put, all it's doing is returning back either JSON or XML wrapped in a JavaScript callback. So as soon as YQL returns, that JavaScript function gets called much like any standard AJAX request, and then the parameter that's passed into that function is the return value from YQL. So it's an easy way of just getting data. All right, so we looked at query syntax, and so you should be familiar with how to use YQL, how to use the service, what it's capable of. Next, we want to drill down into how to actually drive traffic back to your servers. So let's say you have some API available out there. You have a site that you want to build more traffic around, right? So you have some external website that's using your API, let's say eBay. They're implementing your API. They're accessing your data. But really what you want from this relationship is those return eyeballs. You want more people coming back to your service, more people purchasing your products, more monetization of users. And that's really where Open Data Tables comes into play, allowing you a new avenue to reach out to developers to very easily access your APIs or your data streams. YQL Open Data Tables at a base level are really just XML wrappers on top of a data source. They're easy to set up at a base level, but have a lot of complexity in them. We'll go through some specifics on what this complexity entails. So Open Data Tables, in their XML structure, just include basically a couple of nodes, meta node and the bindings node. Think of meta as the documentation for the table. It has some good information in there on the actual table's use, the documentation and such. Bindings is what will tell YQL how to run and access your data sources. So that's really the meat of the table. Let's take a look at the meta tag and see what it has available to it. If we open that up, we see things like author, description, some basic information on what your table's supposed to do and who wrote it. It's good to also include a way of contacting the person. Documentation URL, if you're wrapping an API, link to the API docs. If you're wrapping a data source like an HTML page, link to the page. And then sample query is incredibly valuable, and please, if you're contributing tables, include a sample query, because when you click on the table name, just like I did with the HTML table, it will load up that sample query. It's incredibly valuable to have a real example that people can use just to see what the table's supposed to get. There were a number of tables that have been contributed back without sample queries, and no one knows what those tables are supposed to do. So we have to go find out that information ourselves. So if we take a look at the bindings node and see what that has in its core, we load that up. It has just more XML, as you can imagine. The root node under bindings is our select or insert, update, or delete, whatever type of query we're going to be making. There are a couple attributes on that select. Item path is really good if you're wrapping an API that you don't have control over. Let's say you're wrapping a Yahoo API, for instance. And that Yahoo API returns back the data that you really want, the meat, under node 1.node2.node 3. So really drilled in there. And everything under node 1.node 2 is all documentation and garbage you don't care about. You want just node 3 returned. If you specify under item path node 1.node2.node 3, when the data is returned back by YQL, node 3 becomes the root node that's returned back. Node 1 and node 2 are ignored. You have produces, which is XML or JSON, whichever data structure you want returned back. Your URL structure that you want to call, so this is the API or data source that you want to make a request to. Below that, you have inputs. So these are the keys that people can search on, so select your key from the table. You would have an ID structure, the type of data, param type. This can either be variable to make the data available to the actual server-side JavaScript layer, which I'll talk about just in a couple minutes. It could be map if you want to have a variable object that you can apply, or you can store multiple pieces of data in. Or you can have path, like this one does. If you have a structure of path, what happens is you see how the ID structure of the key is also in the URL in curly brackets. Well, when a user initiates a query against this table, whatever they specify as that key gets applied to that URL when it's called. It's a good way of using some dynamic attributes. We used it when we wrapped the Google Buzz table because their URI structure was basically a static URL with one little parameter for the user's name. So we just applied that in exactly the same way to build their table structure. And then you can add required true or false. If it's required true, the user has to input that value if they want to run the query. All right. I mentioned that we do have a community GitHub repository for you to contribute back your tables to. And in an ideal world, every single person who creates a table would contribute it back so that other people can use the data source. Well, we know this isn't an ideal world, and sometimes you need to secure your tables. Sometimes you don't want data access from data accesses from other people that you don't trust or that you don't know. And that's where the use clause comes into play. We use this in some of our internal tables, some of the things that we haven't exposed externally within Yahoo. You can specify use the absolute URL to your open data table, the XML file, as your table name. Then add a semicolon and use your select as you normally would. It automatically becomes a new table available to you. It's loaded in through the YQL system. If you want to take a look at this in action, you can take a look at the GitHub repository. There's a couple of new PayPal tables that one of the PayPal X members developed, Praveen. And he contributed back transaction search and transaction details. These are wrapping in the PayPal APIs. It's an initial step for us to actually wrap all the APIs that we possibly can within PayPal. If you give me like 15 minutes after this talk, I just need to include them within the community GitHub repository. The pull requests are there, but we haven't added them in yet. So 15 minutes and they will be there under the PayPal folder. All right. So we've talked driving traffic back to your services using open data tables to reach a new audience. We've talked syntax. Now let's talk actually mashing up data and figuring out ways of utilizing users' data streams to essentially mine new social data or social sources so that you can promote your products in a much more targeted way. What we have up here is my standard profile on Facebook. This can easily be any other social network. It could be Twitter. It could be Gowalla. It could be anything that's social. But what we have in Facebook is the connections of the users, the friendships. We have information such as education, work history. We have my likes in there, everything that I'm interested in, all the products that I'm interested in. And most people on Facebook will enter in a huge amount of social data, this huge gold mine of data that can be used to target products. Honestly, it's a huge relationship that's not fully tapped in the way that it should be. You have user relationships. Those likes are expanding the relationship graph to not only include people, but include things, include objects. I like a page. That means I have an interest in it. That is an entity which is part of my social graph. It's important to note because these can be used to your advantage. So mapping down a specific subset of information that's available in my profile. This can be any service again. You can pull certain details like this from any service. You have location-based information, where I am, even if it's just a text that I enter in, or if it's something like Gowalla, my last checked-in place, that's obtained automatically. We have location-based information. My interests, so these are my entities. Profession, to drill down to exactly what I do, what I might be interested in. My friendships, and then dates of interest such as birthdays or anniversaries. If we take these social pieces of data, we can actually extract particular marketing models so that we can sell products in a targeted way. Location, we can take this and develop regional products. If a user's in a particular area, we can say, oh, hey, we have some products out there that you might be interested in. Your interests, product suggestions. You have all this information about entities and what the person said that they are interested in. Why not use it? You can easily create suggestions based on their information. Profession, specialty merchandise. For instance, I'm in the tech field. I expect that a good ad for me might be something around computer hardware, something in the tech field. I don't want to get ads on knitting supplies. It just doesn't interest me. So, targeted advertising to a person's profession, to their likes, can actually drive more traffic, more return on investment through your advertising. Your friendships can drive new avenues for you to reach new people. Suggestions, just like we saw on Amazon. And birthdays and anniversaries, of course, seasonal or targeted products. You can just target these to a particular user. If I have my anniversary coming up and flowers.com pops up, oh, hey, I remember that. This will be a great source for me to get some flowers. All right, this is where YQL execute comes into play. Offering a server-side JavaScript model. Now, I promise I'm not going to jump into JavaScript and give you a whole lecture on what JavaScript is, because if you're working with the products, you're already probably familiar with it. I just want to show you how to utilize it within the table structure so that you can manipulate multiple data sources, access this data to enrich your overall data source that you're getting back. So the things that you can do with the product, with the server-side JavaScript, is to do things like augmenting data. You have a free-form text location, you can get geodata, like we already saw. You can build your own scrape API. Let's say you have a service that you don't really have the engineering capacity to be able to build a full-blown API or build your entire services off of that API that you built. If you use that HTML table and you have public data sources, you can set up a series of tables that scrape your own data and offer to users a quick scrape API. You can do data transformations. If you don't want XML, you don't want JSON, you can return information back in whatever format you want. You can transform that data, such as using XML to convert to Google's KML map format to display a Google map. Recently, I've worked on taking our Firehose data, our update stream, all the activities that happen on Yahoo, and converting that to activity streams format. So that's available. It's just a different version of XML in a different structure. And if you're trying to sell the product, I always tell you to tell the non-technology folks that you're moving all your business logic to the cloud. They love that buzzword. I know everybody loves the buzzword, but essentially all it is huge server farm, redundant servers, quick processing. That's really what you're getting out of it. Okay, so going back to our open data table, opening up the bindings tab, we can actually see the structure that we saw before, the URLs, the inputs. Where execute is going to live is right below that. It's just going to be another little node, an execute node. Embedded within that execute node, you can develop JavaScript, server-side JavaScript. So main difference, if you're not familiar with server-side JavaScript, like Node or Rhino, this is based off Rhino. If you're not familiar with those structures, then it's really JavaScript in a more of a pure form, no DOM accessing, nothing like that. I like to think of it closer to ActionScript in development with all the little bells, without all the little bells and whistles. But you can do things like the user's inputs that they specify on the query. You can get them through the inputs object, like query is one key that the user specified. You can embed XML directly in the JavaScript layer because we have native E4X support. So it's really great for building XML structures. You can do things like making additional YQL queries, getting that data source back and mashing it up. You can make RESTful requests from the server-side JavaScript layer and return that structure in whatever format you want. Just one thing to note, if you are building a JavaScript structure, it's good to wrap your JavaScript in those CData tags so that when the YQL processor goes through your table, it doesn't think that it's part of the table itself and try to process it. So it's really just specifying that this is a server-side JavaScript layer. If you want to take a look at what this looks like in actual practice, I have one little pet project that I worked on one weekend, which was the Global Disaster and Alert Coordination System Tables, or GDAX. Really all it is within 5 minutes of a disaster, they report back the disaster information to these RSS feeds. From those RSS feeds, I have like a little cron set up to pull those RSS feeds at a certain interval. And it'll access that data, and in the server-side JavaScript layer, mash that all up into one object that's returned back. I then check for new disasters that happened, and then push that out to Twitter. So it's a little Twitter bot. That's all it is. But those tables are available to you if you want to see a simple example of how to implement mashups within server-side JavaScript. And if you're really going to gain anything from today, just let it be that YQL will help you build products much quicker. You have these external data sources that have the internal processing power of Yahoo servers. Why not move your logic onto these servers and let us do the processing? it has replaced thousands of lines of my own personal code. I have a love-hate relationship with it that way because I love this code. I put a lot of effort into this code, but my 500 or so lines of data processing, this thing can do in a couple lines. It's really a great service if you're looking to build a product very quickly and work with external APIs. And it's really just that you can run these queries much quicker. They return very quickly in under 100 milliseconds in most cases. It's a really great adaptive service. All right, so here are some of the links that you might be interested in. I'll flip back to this in just a moment once I jump off. So the YQL documentation is available at developer.yahoo.com/YQL. The console is /console on the end. That's your sandbox environment. If you want to contribute tables, it's all under GitHub at github.com/YQL and the YQL-tables repo. And then if you want to contact me if you have any questions, Twitter's good at JC_LeBlanc, or you can email me directly. I'd be happy to answer any questions on any Yahoo APIs or YQL in particular. So thank you very much, everyone. And are there any questions? I'll flip back to this. It's usually the first question. Yes? So that's actually a question that, so the question was, do we offer YQL as a standalone product, or something that you can embed locally within your own systems, right? So that is something that we've thought about. It's something that's been requested a lot. Right now, we do have a system that allows you to take a console and embed it directly on our own production development boxes internal to Yahoo. So we have it ready. It's a little complicated to set up, but we want to find a way of packaging that and releasing that publicly. Right now, it's only private. It's only internal to Yahoo, but this is something that we're actively working towards. Yes? Oh.
Are there any quotas that, like, we can only run X number of queries a day, or? Okay.
Right. So we do have some sort of some rate limiting. If you're calling public data, so that's non-OAuth signed data, it's 1,000 queries per IP per hour. If you're calling private data, so OAuth signed data, it's 10,000 queries per IP per hour. If you have an application ID associated with the queries that you're running, it's 100,000 queries per application ID per day. So the limits are incredibly high. We don't have very many partners that actually need more than that. But if you do, you can contact us directly, and we will take a look at your application and what it's doing, and really just work out a partnership relationship with you, a few agreements, and then we whitelist your keys. Okay. Yes. Oh, I'm sorry.
For the OAuth signed calls, is that OAuth with you or OAuth with the third-party kind of data source?
So that's OAuth. So that really depends. Right now, with to make requests to our private data, that's OAuth signing through us. Okay. Internally within the table, you can make further OAuth signed requests to services to make, let's say, two-legged OAuth requests. A good example of that is our Netflix table. It embeds a JavaScript library to do JavaScript two-legged OAuth within the server-side JavaScript layer and make two-legged OAuth requests to Netflix servers. So internally, or to make the request, you're making OAuth signed to us, but internally you can do further requests.
Okay, so you're passing along like the token to you as well as the third-party
Yeah,
token.
you can access all that data through there. Yeah.
So you showed an example of like I can create an inner query to get results, so like some fields which are not available on the other tables, right? So can we create a view similar way? Like, can we create a view on the existing tables there?
I'm sorry, I don't think I heard that one.
So can we create a view on the existing data, the tables available in the repository, or?
I'm not sure I understand that. I stood that.
A table view?
A SQL view of what the query actually is?
No, sorry. A view is like for a.
So you can actually see the table structure and all the table, so all the records underneath?
So say like I want some particular fields, like for 4 or 5 tables are there, and I want to just pick up 2 fields from one table and 2 fields from another table, right? So I
Right.
can create a view on top of it and then use it. So is that supported in?
So creating views, that essentially, if you're looking for the data sets that you can leverage off of from those external feeds, you can build those individual queries and see them in the console system, so you can see the result set and all the queries within there. And that's probably the best way to visualize the data set and visualize the core. And yeah, that's probably the best way that I can say that you can visualize the data as far as the structure, since it's not really a database as you would. It's just mimicking the functionality and wrapping it. It's essentially just a web service. I'm sorry if I didn't answer your question fully, but if you want, we can jump over afterwards and I can show you exactly what you need. But I hope I answered your question.
So say we have like a website that sells widgets or something, and we make this table for it, and then we post it on GitHub, and that people can use. How are we getting people to use our data? I mean, is it just we have to evangelize it ourselves, or by being there, people will be looking for it? Or
So there's a couple of avenues that you have. First of all, we have a large number of users coming through YQL to look at to use and look at these tables. So you're going to get some native eyeballs directly through the YQL console that way. Second of all, we usually set up partner relationships with a lot of the people who develop the tables. So if we have companies that develop tables with us, we'll try to evangelize those within all of our YQL talks or showcase that data. We offer blog posts that can be written by the table owners. We're always looking for new avenues to promote businesses that are using the service, especially different tables, anything that might be interesting to the YQL community. So we are trying to actively partner with the people who are creating these tables. And that will get you a whole series of new people coming through your systems. Any other questions? No? All right, well, thank you very much, everyone. I'm going to be at the Yahoo booth on the second floor over here all day. If you do have any questions about YQL or anything around Yahoo, I would be happy to answer any questions. Thank you very much.